Hi, in this video, we're going to talk about this neat little topic on lambda function, lambda expression, or just lambda. So all the functions that we have defined up to this point, they all have a name, such as def greeting. The name of the function is greeting. And we can also assign an existing function to a new name, such as in this case. But regardless, uh, this function is always associated with a name. Now, we can also create functions that do not have a name, or anonymous functions. These functions, they have a more formal name called lambda functions or lambda expressions. So first, I'm going to show you how to define them. And to define a lambda function, we basically start with the word lambda. It's a keyword in Python, followed by parameter or parameters of the function, and then with a colon, and then an expression. And this expression is basically, just any valid Python expression, and that becomes the return value of this lambda function. Now, this particular lambda function doubles its parameter x, right? So I'm going to demonstrate it with the Python console. It's just easier for something short. So lambda, this is a lambda function. As we run it in the console, it tells us, okay, you define a lambda function. Well, so just like any function definition, just defining the function itself really doesn't do anything. We have to invoke or call the function to make it do something that we want it to do. So how do we call a lambda function? Well, it's the same way as how we always call any other function, and that is by follow the function with parentheses, and then we put the parameter in the parentheses. Now this lambda function, it takes one parameter, an x. So I'm going to say, let's say the number 10 in here, and then I'm going to run it, and it's going to give us the result of 20. Now, if you need a little more explanation on how this works, is what happens in this case is that lambda function, we called it by, again, follow it with a pair of parentheses and putting the argument in it. And in this case, the number 10 is assigned to the parameter x, right? It's an argument to this function with one parameter x, and then x is going to be multiplied by 2, and that results in 20. Now, a lambda function defined this way can be only used once, right? Because after all, it does not have a name, so we cannot refer back to it. So if we want to use it again, we have to define it again and then give it a different parameter, right? Now, we can, however, assign the lambda function to a name. So this lambda function here, it doubles its parameter. So we can assign it to the name double, and then we can invoke double the lambda function that just like a normal function. So if I run this piece of code, it will give us 20. And in this case, we can then use the lambda function multiple times. But if we explicitly give a lambda function a name, then it's really no longer an anonymous function. So we might as well just define it like a normal function. So this is not necessarily a very typical use case for lambda function, but it's doable. And even though our first example of a lambda function has only a single parameter, a lambda function can have multiple parameters, such as in this case, the parameters are, there are two parameters, a and b, and they are separated by commas. So in this case, this lambda function simply multiplies the two parameters together. So when we call it, we pass two numbers, and we can run it. So 2 multiplied by 3 is 6. Also, lambda function can have no parameter at all. So here, there is no parameter after the word lambda and before the colon, so it doesn't take any parameter. And this function would, when you invoke it, it doesn't take a parameter, and all it does is it's always returning the number 10. Now, Python's lambda functions, they have some limitations. So the biggest one is that they're limited to a single line or a single expression, really. And the results of this expression here is, as we said before, that it is what the lambda function returns. So, and that's why we don't even need the return keyword as we would for a normal function. So that's one limitation. Another limitation is we cannot do assignments inside a lambda function. So an example here, I'm trying to create a variable x equal to 3. As you see, PyCharm is already telling me it's invalid syntax, and when I run it, it's also saying it's invalid syntax. So for that reason, lambda function, at least in Python, is often also called lambda expressions. An expression is something that has no side effect, i.e. that it doesn't change anything. So in this case, it's trying to change something, and that is just not allowed. So lambda function, just like some of the other things we are studying this week, that it's a idea that's been around for a long time. Is kind of based on the idea of lambda calculus, and it's developed way back in the 1930s by Alonzo Church, and as part of his research into the foundation of mathematics. So again, like higher order function, it has its root in mathematics. Now I'd like you to get some practice writing lambda functions. So the first one is hopefully a simple one, that it takes a single parameter and it just returns the parameter itself. Second one takes 3 parameters, and they are hopefully all numbers or even strings, and it just adds all those 3 parameters together. So pause the video and give this a try. And this is the way that I would write it. For the first one, you just lambda x, and all it returns is just x itself, right? Second one is lambda x, y, z, a, b, c, whatever, and we just add all of them together. And I hope you've also kind of call these lambda functions, giving them arguments, and make sure that they do yield the correct results. Now, it's very, very common to combine higher order functions with lambda expressions. I'm going to start with a very simple example that I'm defining a higher order function called apply. It takes another function as one of its argument or parameters, and then another arg as another parameter, and all it does is that it calls the function and pass arg as its one and only argument. So that's this apply function. Now, to use or to call apply function, we can definitely define a named function and pass it to as a parameter to its func argument, but we can also define an anonymous function inline when we call the apply function. And in this case, the lambda function takes a single parameter, x, and it multiply that parameter by 3. Right? So what apply does, it's going to call the lambda function and give it the argument 10. So we would expect the result to be 10 multiplied by 3. That will be 30, and indeed it is 30. Now, this is a fairly trivial example, but I promise I'll show you more practical and useful applications of higher order functions with lambdas.